Assalamu alaikum everyone. So today we are going to see the second part of file interrupt run management. So if you can remember, in our last lecture we saw character stream, we learned how streams and devices work, how to use the command prompts, then we learned file positions, file pointers, we learned different modes of opening a file, and we also learned how to use different functions to work with character streams. Okay, so if you can remember, the last part we had a question or, or confusion, you can call it, that how end of file can be read without having problems. For example, the end of file usually refers to or is equal to -1. So whenever you are trying to read something in characters, so usually you will not get -1. However, when you want to read using binary mode, that means not binary stream, but character stream, there is a mode, if you remember, or there are two modes, reading in binary and writing in binary. So if you want to read or write using binary, in those cases, what will happen if you actually find the -1? How will you differentiate between a -1 and an end of file? Okay, or when you get errors, or also when you get -1. So there are two types of confusions. One is reach the end of file or error, and in those cases you have to understand whether it's an error or an end of file, or you can also it can also be a -1. So this can confuse with these two things. Okay, so after this we're going to learn some functions which help us deal with this problem. Okay, so there are two different types of functions which now can actually deal with error and end of file. Okay, so the first function, intFEOF, which means end of file, this, if you pass a pointer through this function, then it will check whether the end of file has been reached or not. So this function returns a non-zero value if the end of file is reached, and otherwise 0 if the end of file is not reached. Okay, so this is required to differentiate between the errors and end of files. And furthermore, the confusion with binary files where -1 can be faced or can be read, in those cases this function can solve the confusion between -1 and end of file. Okay, the next function is ferror, which actually checks whether there's an error in the file pointer currently. So it returns a non-zero value if there is an error, and otherwise it returns a 0 value. So this is also required to differentiate between the errors and end of file. Okay, so we're going to see how to use these two functions in comparison, or actually with the previous functions. Okay, so let's see an example. So this is another program which is copy.c. So this program basically copies all the contents of one file to another file. So you can actually think of it like the copy function of your computer's operating system. You can copy folders or files, right? So you can think of this as something like that. Okay, so this function contains this program contains two header files. One is the standard input output and the standard library, these two header files. And this is the first time we are seeing the main function with two arguments. Okay, so at first we have to understand what these two arguments are, because previously all we used were void arguments. That means there were no arguments. Okay, so in this case, this very first element or argument is the integer argument count, or argc. Okay, so this tells you how many arguments that you have received, or the main function has received, and this is those arguments. So all the arguments are actually stored as character, or you can call it strings also, because as you can see, this is a pointer, right? But what? A pointer of arrays. So you can consider it as a two-dimensional array. So one dimension is accessed by this array. That means that one-dimensional bracket arrays, and the second dimension can be accessed using this pointer. So it's a two-level of abstraction, you can call it, one with the pointer and another with the array. So we get a two-dimensional array. Okay, So the very first element of this array is actually the name of the function itself, because if you can remember from the command prompt, we used to write the name of the program, right? So that is the very first argument, and the next argument that we give, that will actually be the second argument. So if we give another argument, then argc will be equal to 2, and if you give only one argument, that means the name of the program itself, then the number of arguments is actually 1. Okay, so now the very first line is declaring two file pointers. One is the from pointer, which will help us read from a file, and another is to pointer, which will help us write to a file, and this is a character which we'll be using to read and write. Okay, so this is the check for whether the correct number of arguments have been given or not. So as we want to write from one file to another file, we need 3 arguments, right? One is the name of the program itself, copy.c, and the other 2 are the name of the source and the name of the destination. So the source is from where we'll be reading, and the destination is where we'll be writing. Okay, so in any case, if these 3 arguments are not given, then you have to exit the program, because you will not be able to run the program, and you have to print this error message, okay, that the usage is like this. You have to write the name of the program, which is copy, then the name of the source file, then the name of the destination file. Okay, so afterwards, if it is correctly given, the arguments that is, then the program will open the source file using the same commands as before, which is fopen. So we are storing the file pointer in from. Okay, and now notice how we are opening this file. We are opening this file in using 2 things. One is the argument, which is the first part. Okay, the first argument excluding the file name or the program name. So actually you can call it the second argument. So this argument is the name of the source file. Okay, and you have to open it using binary mode, because in this way you can actually write or read using any file. Okay, so if this whole thing is equal to null, that means the file was not able to be opened, so we will be just printing cannot open source file, and then we are going to exit the program. Okay, otherwise we are going to continue. So remember, the second argument is the source file, and the third argument is the destination file. Okay, so now we are going to open the destination file, and we are going to store that pointer to 2. Okay, so we are going to open using the third argument, which is 2. 0 is the first argument, 1 is the second argument, and 2 is the third argument, and we are going to open it in the writing binary write mode. Okay, so if we cannot open it, that means it equals to null, then we'll just print cannot open destination file and exit. Okay, so then we are going to copy the file from to 2. Okay, so this might sound confusing, so we are going to copy it from here to here. Okay, so this is the while loop, and inside the while loop we are checking whether we have reached the end of file or not. So this is the function for checking end of file. Now if you remember, if the end of file is reached, then it will return a non-zero value, otherwise it will return 0. So if it returns a non-zero value, that means the end of file has been reached. Okay, so until the end of file is reached, we have to keep reading, which is why we used a not sign. So not end of file, that means until the end of file is reached, we will be reading. Now remember, you cannot use to here, you have to use from here. Okay, because we are opening to as a new file, and so it will always be empty, and the from file is from where we will be reading. So we have to check whether the end of file is reached or not with respect to the from file. Okay, so inside the while loop we are reading using fgetc and storing that information or character in ch. Then we are checking for errors. If there is an error, then we'll print error reading source file. Okay, now inside the while loop, after checking for the error, we also check for end of file again, in case we reach the end of file after reading using fgetc. So then we check for error. Okay, but before checking for error, we also write using fputc. As you can clearly see that this ch is the input that we took from using fgetc, and this ch we are again using to write into which file? This file 2. Okay, so whatever name we give to from and to, they will be using those files. Okay, So here we are again checking for error, but now in the destination file, not the source file. This is for the source file and this is for the destination file. So the same way we're checking for error, and if there is an error, we print it, or we print the error message, which is error writing destination file. Then we exit from the program so that it doesn't crash. And if there is no error, then this loop will be running until the end of file is reached and the whole file will be copied. So if the file can be closed properly, then it will not return an end of file. Okay, otherwise it will return an end of file, in which case we'll print the error, that error closing source file. Okay, and again we're using the same code to close the to file. So after all this is executed, the file should be copied from one the text should be copied from one file to another. Okay, so let's say the contents of our folder. So here we already had a file, if you can remember, which is file.txt, which contained this text from the previous lecture. So we'll be using this. Okay, so now we have to call the command prompt. So Windows R, then cmd. Okay, and then we have to go to the directory D. Now we have to go to this folder where everything is. Okay, so here we are going to write cd for change directory and then paste it. So we are where we need to be. Now we need to compile this program, right? Copy. This is the name of the program, right? If you can see here, copy.c. So we're going to run this program. So gcc copy.c, and if you can remember, we have to give another option if you want to keep the name same. So we're going to give -o copy, so the same name will be there. So after compilation, if you can see, a new exe file has been created, copy.exe. okay, so if we copy, or if we use this program directly, copy, so as you can see, the syntax of the command is incorrect. Why is that? Oh, because probably there already is a function called copy in the console, so we are going to give it another name. So let's just give it the name cpy. This shouldn't be there. So copy.c -o, and then we are going to write cpy. Okay, so another program should be created, cpy.exe. So we're going to delete the copy here. Now what do? We just call the cpy function. Okay, so as you can see, when I've called cpy, it's saying that usage is this way. Okay, so ignore this o, because now we have changed the name to cpy. So now the name should be cpy. Okay, so cpy source destination, this is the usage. Now if you can remember, when is it supposed to print this? If the number of arguments is not 3. So we did not give any text file name or any file name, so this is why it's showing an error. So what we're going to do now is we're going to give the name of the files. So as we already have a file called file.txt, we're going to use this as our input file and another file test.txt as our output file. Okay, so we're going to write cpy, then the name of the file is file.txt, and the name of the other file is test for test. Okay, so now it ran properly, right? But what happened? We didn't see anything. Let's check. So as you can see, another file is created here, which is test.txt, and the previous file is file.txt. So if we check file.txt, this was the content we already checked before, right? So the same content should be there in test, right? And yes, it is there. So the copy program is working properly, and the new text file was created using this command. Okay, now if I want to change it, I can also change it. For example, let's say I want to read from the test file, and then I want to copy in another file, which is, let's say, trying.txt. Okay, so another text file should be created, which is trying.txt, and the contents are also again same. So this is how actually you can use end of file and errors to check for errors or end of file. Okay, so it is working properly without even writing equal to end of file. So the next two functions actually give us more power over text streams. Okay, so these two functions are fputs and fgets, and if you can remember, they're actually quite similar to puts and gets, which we already used. The only difference is here we have to pass the function pointer, and in this case also we have to pass the function pointer. Okay, so in case of fgets, there is another new thing which is int num. Okay, so we're going to see what all these things mean. So in case of the very first function fputs, it is similar to its counterpart puts, except that a file pointer is also required and it does not write an extra new line character. So what does this mean? If you can remember, when you use puts, whenever you write a string, the cursor automatically moves to the next line. Okay, I have already shown this in class. So if you can remember, if you write fputs, you do not have to separately print a new line, it automatically prints it. But this fputs does not print the extra new line character. Okay, so this is the difference between this fputs and that puts in terms of printing. So this writes a string or character array to a file, just similar to puts, which was used to write to the screen or console. Now we are writing it to a file. Okay, so this function returns an end of file for errors and non-negative values if the puts function or fputs function is successful. Okay, so next we'll see the fgets function. Okay, so this function contains same like the gets, but the gets did not contain these two things, int num and file. If you can remember, gets only contained what? The character at a character pointer. Okay, so the new thing that we have here, num and file pointer. The file pointer is the same as puts. This is the name of the file or pointer of the file from where we want to take input. Okay, so similar to its counterpart puts, except that it's similar to its counterpart, except that a file pointer is also required, and it retains or keeps the encountered new line character. So if you can remember, in gets, even if you give enter, it did not store that enter, right? But now fgets actually stores that new line character. Okay, so it reads a string or character array from a file and also reads a new line character. Okay, so these are the differences between that puts and gets and this fputs and fgets. Okay, so there are two other functions which are also same as printf and scanf. They are fprintf and fscanf. Okay, so these two are also same as printf and scanf. The only difference is the file pointer and file pointer here. Okay, so fprintf prints into this file and fscanf scans from this file. Is it clear? So there are many examples for these codes which are available in page number 265, 271 and 275 of chapter 9.2 of Teach Yourself C. Okay, so I'm still going to show you these examples in code blocks. Okay, so next we're going to see the higher level functions that we learned. So in this code actually we have another header file which is string.h, because we will be working with some functions that use strings or functions to manipulate string. So the main function is similar to before. There is an input argument count and an input argument string. Okay, so this is the file pointer and this is the character array to store our strings. So now in this program we will have only two arguments. Why? Because we are just reading. Okay, so this program will contain the name of the program itself and the name of the text file that we want to read. If the text file is not written, then the similar error message will be given that you have to specify the file name. Okay, so the file that we have to use for output, we are creating, the file that has been passed as argument, we'll be using that for our output. Okay, so we are opening that in writing mode. As you can see here, w, and argument 1 means the second argument, okay, which is the name of the text file or the file that we're going to use for output. Okay, so if you cannot open that, that is if you get null while opening it, then you have to print cannot open file as an error and exit the program. And if this is not exited, that means there is no error. So we're going to print enter a blank line to stop. Okay, so when you are writing something on the screen, if you give a blank line, then the program or the C program will actually stop taking input from you. Okay, so after that, each time we are going to print this colon, and then we're going to take input using the gets function that we learned before. Okay, not the fgets but the gets. Okay, so we are going to copy that string into we're going to copy the new line character into strings to add a new line, because now the gets does not store a new line. Okay, the fget stores a new line, but the gets does not. Okay, I just cleared that up a few minutes ago. So if the str pointer is not equal to new line, that means there is no new line, or the whole string is not a new line, then we're going to print it into the file. Otherwise we are going to stop. Okay, so this blank line is supposed to give me a new line character and nothing else in the string. So only in that case I will break. Okay, otherwise I'm going to print. Okay, so the break condition is here, the same as this condition. Okay, so if my str is not equal to null, new line, then it will continue, and if my str or my string is equal to new line, then it will break. Okay, after that we're going to close the file. So now we're going to open that file again, the file where which we wrote just now. We're going to open it again in read mode, and again the error checking, and then we're going to read using the fgets. Okay, so as you can see, in normal gets there is no number of characters that you have to take as input, but in fgets this is there. Okay, so in fgets you have to give the character pointer the name of the file or the file pointer, and also the number of characters that you want to take as input. And if you can remember, we had 80 characters, right? So which is why we are taking 79 characters as input. Why? Because the last character we need for null character. So if the end of file is reached, this is the checking for end of file, then we are going to print the whole string. Otherwise we are going to keep on taking input. Okay, so here in the while condition we have the same condition as this one, which is our breaking condition. Okay, so if the end of file is reached, then the while loop will break. Okay, so just notice one thing here, that as fputs does not print an extra new line just like puts, because puts used to print an extra new line, but fputs doesn't, which is why we are adding a new line here. So if fputs works like puts, then it will print two new lines. Okay, otherwise it is going to print like normal. So we are going to check this now whether it's doing that or not. Okay, so what are we going to do? We are going to run this program. So higher level dot c, right? GCC higher level dot c, and what name are we going to give it? Let's just call it higher level name. Sorry. Okay, so done. Now we are calling that program higher level. Okay, so the text file that we're going to use is test.txt. so this will also be a demo of whether the text file is replaced or not, because if you can see, this is a file system test. This text is already there, so we're going to rewrite on this. Okay, so enter a blank line to stop. So the first line will be this test file is, then I'm going to press enter, going to be rewritten, then full stop, then again enter, check whether extra new lines are added or not. Okay, so it's not stopping, right? Why? Because I haven't given any empty line with only new line. Okay, so now I'm going to press enter, so it's going to be an empty line and the program is supposed to stop. So yes, it stopped and it prints the whole thing again. this text file is going to be rewritten. Check whether extra new lines are added or not. So as you can see, there is no new line added, right? No extra new line is there. But even then, we're going to check the text file. Okay, so the text file is also rewritten. Okay, so this is how actually you can use the higher level functions to implement higher level text works, for example using gets or puts or printf and scanf. Okay, but I'm not going to show you printf and scanf now. You can do that as an assignment. Okay, so next we are going to see binary stream. Okay, so character streams perform character conversions on numeric data. What does it mean? For example, if you read 25, which is actually a number, right? But even that number is converted to ASCII characters. So 2 is converted to its ASCII code, 5 is converted to its ASCII code, and then it is stored as characters. Okay, this is if you use gets and puts. Now you might be wondering then that fscanf and printf should be efficient, right? But no, even those things read as characters or actually read as numeric data and then convert it to binary, because actually everything is stored as binary, not as characters, okay, or not as numbers, only in binary. Therefore the binary stream is very efficient because it directly reads as binary and writes as binary, not text, not numbers, nothing. Okay, and as the form is fixed, there are no separate functions like fprintf, fscanf, fgets, fputs, then fputc, fgetc. No, only two functions. Okay, so this makes binary stream very easier and very efficient. Okay, so what are those two functions? One is fread for reading and fwrite for writing. Okay, so there are some input parameters here. The first one is buffer. Okay, so this is the buffer that we talked about earlier in the last lecture also. So the buffer is used to save input from file to buffer. Okay, then we have another size here. Okay, and we have another variable type, which is size t. So what is this size t? This size t is actually a macro which is already defined in stdlib or standard library. So this std t is actually a sort of unsigned integer which can be used to store the size of each object. Okay, in this case the size of each string we are taking, but as we are working with binary stream, the objects might not be string. So this is why actually we call it objects instead of strings. Okay, and then this size t is another size which actually tells you the number of objects. So this is the size of the objects, and this is the size of the objects, and this is the number of objects. Okay, and this is as usual the file pointer of the file from where we're going to read. Now one thing to notice here is this type. This is a void type, right? So you know what void is, but is there any type like void? No, right? Void means nothing. So this means that this buffer can be of anything. You can store strings, you can store integers, you can store binary values, anything. Okay, so whenever you see void pointers, that means it is universal and it can store anything or point to anything. Okay, so this function returns another unsigned integer or size t, which is the number of objects that were successfully read. Okay, so the other function is fwrite, which also works like fread because it has a file pointer and it has a num, which means the number of objects that you have to write, then the size t, which is the size of each of those objects, and then this is the buffer. So you are going to write from this buffer to the file. Okay, so the only difference between write and read is read takes input from the file and stores it to the buffer, and fwrite writes from the buffer to the file. Everything else is same. Okay, so the examples are available in chapter 9.5 of page 281 of the same book, that means Teach Yourself C. And now I'm going to show you the codes. Okay, and a brief explanation is given here. Oh, here it's written that stdio.h. So one thing, just remember that size t and null, both of these macros are defined both in stdio.h and also stdlib or standard library. Okay, so let's see the example. The example is this one, binary. Okay, so now we are going to see what it does. So there are two lines, the header files, the main function. So now there is no input parameter. only void, that means no input is there. So this is a file pointer, this is an integer. So we're going to we're going to write into the test text file, okay, and we're going to write in binary, okay, and if we cannot open that file, then we're going to exit, okay. So we have the number I equal to 100, okay. So see, we're going to write that using fwrite, but here we're writing and I because we're using the address. If you can remember, the buffer is a pointer, so we have to pass the pointer, and I is an integer. So if I write I and I, we are actually passing the pointer of I. So then we're saying that the size of the object is 2, okay. So we are not going to write more than 2 things at a time, but we are just writing one thing, so there's no problem. And this is the number of objects. We are going to write only one object, okay. So this is the object which is I equal to 100, and this 2 means we are going to write an integer of size 2 bytes, okay, and we are going to write into this file pointer which we just opened. So if you cannot write, we are going to print error occurred, okay. So then again we are going to read from it, and if you cannot read, then we're going to print that we cannot read it, okay. So notice one thing, we are opening both in binary, we are writing in binary and reading in binary, but we are using a separate stream which is the binary stream, fread, okay, and fwrite. So when we are reading, again the same buffer, and we are going to store it, and if this is not equal to 1, that means that we were not able to read it, okay, because if you were able to read it, it is supposed to give a non-zero value, but now if it gives a 0 value, then it will be not equal to 1. So read error occurred, okay. So this sort of works like fprintf and fscanf, okay. So if you are successfully able to scan something, then it returns a non-zero value. If it returns 1, that means you are able to read 1 value. If it returns 2, then you are able to read 2 values, and 0 means no value were able, the program was able to read no value, okay. So here if it equals to 1, that means there was no error, but if it is not equal to 1, that means no object was read, so that is an error and the program will break, okay. And afterwards it is going to print that value as an integer, okay. So let's run this, gcc binary.c -o, then binary, okay. So it was compiled without any problems, and then we're going to call it. So it printed 100 properly, right? But what is actually there in the file? Don't we have to check that? Let's see. Test, right? So it's written D here. Why is it written in D here? What is the ASCII code of D? If you can remember, the ASCII code of D is 100, right? Small letter A is 97. So D is 100. So it is stored as a character, but it is read as binary and written as binary. Is it clear? Okay, so we are going to end our class here before we read file access, and we're going to see a separate small video for file access. Okay, so if you have any questions, you can ask, but I'm going to upload all the videos together, so you can ask all the questions together.